So 11.4 is the binomial theorem. And so basically we're going to be using this stuff to help us expand binomials. So when we have something like x plus y raised to some power, it's going to help us to expand that correctly. And so there's a couple different ways that we can do that. We can memorize the patterns like we've done before. So like for a perfect square trinomial, for example, like we could do it that way. The cube of a binomial, you've memorized that before. But this is going to show you the pattern of how that actually works, because I honestly think it's easier to do it this way than to do it the way that just memorizing it in most cases, especially as you get into larger things. And so the first thing we're going to go over is Pascal's triangle. Anybody ever heard of him before?
Sounds familiar.
So basically he found this like pattern of, again, it's going to be how that we can factor out binomials to whatever power. But we're going to have, I'm probably going to go down to like row 5, maybe row 6, but row 0 is 1. Row 1 is 1, 1. Row 2 is 1. Then we start from here adding. So the only ones you have to like out and out memorize are these, the row 0 and row 1. So then this is 2. We add these numbers together and then 1 there. And row 3 is 1. So the outer edges are always going to be 1s. Then 1 plus 2 is 3. So there's 3 there. 2 plus 1 is 3. And then outer is 1. Row 4 is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And we end with a 1. Row 5, start with 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And we end with a 1. And this could keep going, and we would keep doing the same thing over and over again to find the patterns. And you're probably like, well, what in the world do these numbers represent? Well, these are the coefficients that go in front when we are expanding something. And so basically if I had let's say x plus y to the 5th, then I'm going to use the coefficients from row 5 to write this out. The first term is always raised to a power, whatever this power is, in descending order. So the first one will be x to the 5th, the next one will be x to the 4th, x cubed, so on and so forth. The last term is always in ascending order, so it would start out where it doesn't even have one. It would be like y to the 0 power, then y to the 1st, y to the 2nd, and so on and so forth all the way out. The numbers that go in front of these terms are from row 5 then. So this would be, the first number is 1, but we don't need to write a 1, obviously it's understood. And then it's the first term raised to the 5th power, the last term raised to the 0 power, so I don't write that, plus 5, first term raised to the 4th power because it's descending, second term raised to the 1st power because I'm ascending, plus, next number is 10, x cubed, y squared. I've got another 10, so plus 10 x squared y cubed plus 5x y to the fourth, and then 1, which again we don't write the 1, but then x would be gone because this was x to the first, so now it would be gone, and we would have y to the fifth. So if you look, x's we have to the fifth, to the fourth, to the third, to the second, to the first, to the 0. Y, it's to the 0, to the first, to the second, to the third, to the fourth, and to the fifth. And the numbers are from row 5 of Pascal's triangle. Okay. Let's see. If you have this, how would you read that?
N factorial.
Oh, you do know what it is. Usually people say an exclamation point.
I was gonna say that.
Should I ask you then? Okay, so it is not just an exclamation point, it is in factorial. Do you know what it means?
Yes. You take
Like if you had 4 factorial, what would you do?
It would be 4 times 3 times 2 times 1.
Yep, so it's all of the numbers added up, or not added up, multiplied, but in like descending order. So wherever number it is, so if it's 10, it's 10 times 9 times 8 times 7 times 6 times 5 and so on and so forth, all the way down to 1. And so this is for any positive integer n. This would be n times n minus 1 times n minus 2 times ... times 3 times 2 times 1. Now, let's see. What then is 0 factorial?
0.
What's any number raised to the 0 power? So this is also 1. Not for that reason, but it just is. That's more just like a fun fact Jeopardy question. You're not usually going to have a 0 factorial on a math test. Not going to say I couldn't put it on there, but typically if I'm going to have you do it, we're going to just do it as it is. So this stuff can be useful. You're probably like, well, why do I need that? It can be useful in helping us to write out our binomial coefficients. Let's say that I wanted this to the 10th power and I didn't feel like writing out Pascal's triangle to the 10th row. We can use this to help us to find what that is. And so the binomial coefficient now, this doesn't mean this is the most efficient way to do this, but this is a way that we can do this. And I'll show you, there's a trick on your calculator as well. But for non-negative integers, n and r, with r less than or equal to n, the binomial coefficient is defined as it's a little n, a big C, and a little r, and that's what it looks like on your calculator. I'll talk about that in a second. is equal to, now this is a parentheses with an N and an R in here. Now, it is not a fraction, okay? This is N things, take an R at a time. So it's how many of them do I want based out of how many I have total. But again, it is not a fraction. It's just a different way to represent what's written right here is the first thing. This is equal to N factorial over R factorial times N minus R factorial. So on your calculator, depending on, do any of you have the new one that graphs in color? Or all of you have the one that looks like this? Okay. I have no idea what yours is going to do then. So there's not a button, but when you go to math on your calculator, okay, there's something that looks like this. So let me show you. So I'm about to lose my book off the side here. So under math, oh, my batteries are low. I just need to change them. Then we're going to go over here to probability, which is the far right. It's PRB. And you're going to notice option 3 says NCR. So on mine, if I click this, mine does not give me little boxes to type the numbers in. So it's taking the most recent thing that I had, or I can type over it. So if I had, let's say, 7 things and I want them 3 at a time, this is how many possible ways can that happen. There are 35 different ways that I can have 7 things taken 3 at a time. Now, if you have the newer calculator, so cashiers, maybe this way, then when you hit that button, what it's going to do is it's going to bring up a little box right here and a little box right here. You're not actually going to see the letters N and R, so you just have to know which one's which. It's always the total number that you have and then what you're looking for. But you will just type in the boxes if that's the case. But if you have the calculator like me, you'll just type it in front and at the end. So before I ever type it in, so let's say I wanted to do, let's see, 5, then math, NCR. And so notice it just took the number that I had already typed, which is fine. And then let's do 3. Then you'll notice if I go over here in the 5th row, the 3rd spot is 10. And notice it gave me a 10. Now, there are ways that I can do this so that it gives me all the numbers at once. We have to use some fancy bracket things to make it happen. But I could do 5, math, probability, NCR. Now, there's curly brackets, the curly brackets are above the parentheses. So if I hit second and then the parentheses, it brings that up. And if I want this whole row, row 5, I can do 0, comma 1, comma 2, comma 3, comma 4, comma 5, comma 6. Because there's 6 things in this row. There's always one more than however many's in there. Or wait, I lied. It'll give me the numbers that I need. So I'm going out to 5. That is 6 numbers because I start with 0. That's why I said that. So you can't go out farther than whatever total number you have. So if I'm in row 5, I can't have more than the number 5 here. So if I hit that, notice it produces the numbers 1, 5, 10, 10, 5, 1. It produced that whole row for me. Okay. So there's different options. Most likely one of your questions on your quiz and maybe probably on your test will say to write out the first 5 rows of Pascal's triangle. When I say that, I mean out to row 5 because that first one is row 0. Okay, so whatever row I'm saying right out to row 6, then you'd go to what like visibly would be row 6. right? Not this first one doesn't count. If you're like, well, I don't remember what Pascal's triangle is, you can do it this way by typing them in every time. Okay, if I had a binomial raised to the 10th power and I didn't want to sit here and keep going for 5 more rows of Pascal's triangle, I can use that function on my calculator to do it. Okay, and it makes it nice and easy. Now, if you use the method that's written here in green, that finds you one number at a time. Which is fine, but you probably don't want to be doing that over and over and over and over again, because that's just going to get really annoying. But if we want to prove that this works, I did 5 NCR 3 a minute ago, which we said was 2, so I'll show you that by hand it would still be the same thing. So 5, and I always write it like this just because this is how it's written on my calculator. You don't necessarily have to write it that way, but anyways, this would be the same as 5 take 3. So then it will be 5 factorial over 3 factorial times 5 minus 3 factorial. So what this means is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And obviously we don't really need to write the times 1s, right, because it's not changing anything, but just for the visual for right now. And then times, well, this is really 2 factorial, so this would be 2 times 1. Then what I can do is I can cancel things at this point, and so I can say, well, 3 times 2 times 1 cancels with that, 3 times 2 times 1. Then down here, well, I obviously don't really need the 1. Well, 2 and 4 can cancel, and that can give me 2, and so that would be equal to 10. So doing one piece at a time, I will get the same thing. If you didn't have a calculator, that would be how you'd have to do it. Now, a lot of times, rather than writing this way, instead, I would have gone from here, and I would have said, well, I know 5 factorial and 3 factorial are going to basically cancel each other, so that all I'm left with is 5 times 4. So I would have gone straight to 5 times 4. I would have said, well, that's 2 factorial. I don't need to write the 1. And I would have just gone straight to over 2. Because I just know how reducing and canceling works. But I want to make sure that, you see what's actually happening here. So if you need to write the whole thing out, write it all out. But if you say had 15 factorial, you probably don't want to write the whole thing out, right? If I had 15 factorial over 13 factorial, I'm going to know, well, 13 factorial is 13 times 12 times 11 and so on and so forth. Well, 15 factorial is 15 times 14 times 13 and so on and so forth. So I'm going to go straight to just 15 times 14 here is what I'm going to be left with instead of writing out the whole long thing. Again, not that big of a deal as far as what we're doing because you do have a calculator as well. And your calculator has a factorial button on it. It is under math and probability as well. It's option 4. And so you have that in the event that it's needed as well. Now, the binomial theorem actually written out, just so that we can see it. We've already kind of done this in writing out the one example that we did. But the binomial theorem is the way that we would expand x plus y raised to the nth power. Okay, and so what that tells us is that we would have the first power raised to the n plus, then it would be n things taken one at a time, or NCR, times x to the n minus 1 y plus n things taken 2 at a time, x to the n minus 2, y to the 2, and so on and so forth. Or well, I'll go ahead and write one more. N things taken 3 at a time, x to the n minus 3, y cubed, again, so on and so forth, plus n things taken r at a time. I don't even know what number I'm at yet. And that's x to the n minus r, and then y raised to the r. So y will always be raised to whatever that bottom number is. X will always be n minus whatever the bottom number is. And then finally, all the way out to the last term would be n things taken n minus 1 at a time. X, y to the n minus 1. And then, well, I guess technically the final term is y to the n. So that's obviously it written very expanded, right? But that's just saying this is how I could find each of these numbers if I didn't want to do Pascal's triangle or I wasn't using my calculator. That's how we would find each of the numbers that goes in front. And they're all patterns, which is nice. Now, I don't necessarily care with the problems that say to write the binomial expansion of each expression. I don't really care if you use the binomial theorem, if you use Pascal's triangle, if you use your calculator to write out the numbers. I don't really care as long as you get the right final answer, the method that you use to get there. I don't care. So even if the book specifies you have to use the binomial theorem, you have to use Pascal's triangle, like, I don't care. I just want you to get to the right final answer. So the first one say to evaluate the binomial coefficient. So 12 is 5 factorial over 2 factorial, 3 factorial. So this would be equal to 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. So at this point, I would cancel out this 3 times 2 times 1 on the top and the bottom. Obviously, that other one can go. 2 goes into 4 2 times, so that would be 10. So again, that would be, well, that was pretty much just a flip of the one that I did up here earlier. It was 5 taken 3 at a time. This would have been 5 taken 2 at a time, technically. Let's see, 18. 9 taken 3 at a time. So the same instructions, just written a different way. Then writing it as a binomial coefficient, it would be 9 factorial over 3 factorial times 9 minus 3 factorial. So this is one where I may not want to write everything out, okay? So this would be 9 factorial over 3 factorial times 6 factorial. Well, I know that 9 factorial and 6 factorial are the same as soon as I hit 6, right? So I have 9 times 8 times 7 and then 6 factorial, and then that would all cancel. So I'm going to write this as 9 times 8 times 7. And if I wanted to, I could then write 6 factorial over 3 times 2. I'm not going to write the 1 times 6 factorial if you want to write it that way. And then show that you're canceling those 6 factorials out. That's another way that you can do it to visually see it. And then I can say, okay, well, I know 3 goes into 9 3 times. 2 goes into 8 4 times. So now I'm left with 3 times 4 times 7. And what's that, 12 times 7, 84. So that would be 84. All right, the next ones want us to write the binomial expansion. So 32 m plus n raised to the fourth power. So I can do this, well, a couple of different ways. But the first one is I could go back to Pascal's triangle. This is raised to the fourth power. That means I need row 4. And I could pull the numbers 1, 4, 6, 4, 1. Okay, there's always going to be one more term than whatever your power is. So in this case, there's 4 terms. There's 4 power. It is raised to the fourth power. It has 5 terms. There we go. So I could just use these numbers because I've already written out Pascal's triangle, or I can do it using my calculator. So I'll do this one with the triangle, and then the other ones from here on out, I'll use the calculator method. So 1, 4, 6, 4, 1. So a lot of times what I'll do when I go ahead and have this is I'll write out the terms. Now again, I don't normally write the 1, but I'll just do it for right now. So 1, 4, 6, 4, 1. And then we just go in order. So this would be m to the fourth power plus, I have to shift this over, 4 m to the third power. And now I have n to the first power, so I'll just have n, plus 6 m squared, n squared, plus 4 m n cubed, plus 1, m is gone because it's raised to the 0 power, so then n to the fourth. And like I said, normally I remove the 1s just because you don't need them. If you have them, it's not wrong or anything. You just don't. It's understood that there's a 1 there. So we have expanded that binomial. Now, not bad when it's just like m and n, x and y, something like that, right? But sometimes these things have a number in front of them, or notice this was a positive sign here, okay? This expansion works for when it's positive. If it's negative, then I have to treat that second term as a negative term because it's going to cause signs to change in some cases. So that would mean if I had something like 34, a minus b raised to the 7th, then the way that I'm going to think about this is a plus negative b, and I'm going to put that in parentheses, raised to the 7th like that. Now, the way I find the numbers that are going to go in front is I'm going to go to my calculator. So I'm going to do 7, math probability, NCR. And then I'm going to do the thing where it's going to give me all the terms. So the curvy bracket, I start at 0 and I go up to 7. So 0, 1, 2, 3, 4, 5, 6, 7. And close off that bracket there. Now, I can't see the whole thing on the screen, so I'm going to have to arrow to the right, but I'm just going to follow this along. So this is 1, 7, 21, 35, 35, 21, 7, and 1. That would be, it's always a pattern. So once you hit the point where it starts to read a diff, like it's going back in the numbers, it's just repeating the pattern on the other side. So that means that the first term is going to be obviously 1. That's always going to be the case. So I'm going to come down here. So this is going to be a to the 7th. Plus, the next one has a 7 in front, a to the 6th. Now, when I do this, this is going to be a negative b. So I'm going to use parentheses here and do negative b. That's just raised to the first power. Plus, the next number is 21, a to the 5th. Then I've got negative b squared. Plus, the next number is 35. That's going to be a to the 4th. then negative b cubed, plus, the numbers start to repeat here, 35, a cubed, negative b to the fourth, plus 21, and again, you may have to arrow over, a squared, and then negative b to the fifth, plus, I'm going to come down here and write it, 7a, and then negative b to the sixth, and then finally, plus, it's just a 1, a is gone now, negative b to the seventh. Okay, now that's not my final answer in this case because I need to deal with these negative signs in here. So anytime we have a negative raised to an odd power, it's negative, or a negative raised to an even power is positive. So basically these terms are just alternating positive, negative as far as that goes. So this would be a to the seventh. This is just raised to the first power, so minus 7a to the sixth b. A negative raised to an even power is positive, so plus 21a to the fifth b to the second. Plus, or actually not plus. Negative b cubed is negative, so minus 35a to the fourth b cubed. Negative raised to an even power is positive, so 35a cubed b to the fourth. Negative raised to an odd power is negative, so negative 21a squared b to the fifth. Plus, determined to fit this on this line, b to the sixth, so this is 7a b to the sixth, and then finally minus b to the seventh, because that was a negative raised to an odd power. So notice the signs are alternating when I have that negative in there and it's raised to an odd power. Any questions on that one? Let's see. One more here. Let's do 40. This one is 4a minus 5b raised to the fifth. So notice these ones, the terms have a number in front of them. Okay, that's going to make this one even longer. Okay, now we've already written out the fifth row, so for the sake of time, I'm just going to look up here. The numbers are going to be my 1, 5, 10, 10, 5, 1. Okay, the last row that I've written out here, row 5, because this is to the fifth power. So, this is entirely a first term, and then this is the second term. So this is really like 4a plus negative 5b, and I can do that, all raised to the fifth power. Okay, and that's just so that I can visually see what's being raised. Okay, so it's not just the variable that's getting raised to the power, it's that whole thing. Okay, now some of these numbers are going to get mighty large, so we're going to have to just be mindful of that as we're going through and multiplying. But I've got 1, 5, 10, 10, 5, 1. So, right, make sure that was the right numbers before I get started. Yep. All right, so the first term raised to the fifth power, so that's going to be 4a raised to the fifth plus 5. First term raised to the fourth power, so 4a raised to the fourth times last term, negative 5b, plus 10. First term cubed, so 4a cubed. Then negative 5b squared plus 10 times first term squared, so 4a squared, times negative 5b cubed, plus, I'm going to go down to the next line here, 5 times first term, 4a, times the last term, negative 5b raised to the fourth, and finally the last term raised to the fifth power, so negative 5b to the fifth. All right, so now I need to do some multiplying. Probably going to want my calculator at this point because these numbers get a little bit large. And like, for example, I don't think we know what 5 to the fifth is off the top of our head. I'm not going to say we couldn't sit here and figure it out, but it's not something that just comes to me. Like 5 squared, obviously I've got that. But not only do I have, say, 5 squared, right? Or, well, yeah, you know what I mean. But I also have that multiplied times 4 cubed, and I have it multiplied by 10. So I'm probably just going to want to use my calculator to find that number just to make my life easier. So I don't know what 4 to the fifth power is off the top of my head, so I'm going to do 4 to the fifth, and that is 1,024, and then a to the fifth, plus the next one I have 4 to the fourth power, and that's being multiplied by 5 and negative 5. So times 5 times negative 5 is negative, so this is actually a minus sign here, 6,400, a to the fourth b. And I'm still watching those variables because not only am I raising the 4 to the fourth power, but that a is also being raised to the fourth power. Then the next term, it's going to be positive because 5 squared, or negative 5 squared is just the same as 5 squared. So I've got 10 times 4 cubed times, well, 5 squared is 25, so times 25 is 16,000 a cubed b squared. This next term is going to be negative. Then I've got 10 times, well, 4 squared is 16, so I'm going to go ahead and call it that. And then I've got 5 cubed is 20,000 a squared b cubed. Next term is going to be plus. I'm going to have to go down here because these are some big numbers. This is going to be 5 raised to the fourth times 20, which is 12,500 a b to the fourth. And finally, it's going to be a minus. 5 raised to the fifth is 3,125, and then b to the fifth. So that is the expansion of that. Obviously super long, but you got your calculator there. Just take advantage of it to help you multiply. Obviously, I used Pascal's triangle because it was already written out for me. I would recommend when you do your homework that you do at least one using Pascal's triangle and then at least one using your calculator where you're writing out each of the terms, or like where you're doing the little curvy bracket thing, just to make sure you know how to do both. Because that way you don't want to get stuck and be like, oh, I forgot how to write Pascal's triangle, but at least you can use your calculator or vice versa, right? Obviously, we can write out Pascal's triangle, but at a point, you're not going to want to keep writing it out because it's going to get ridiculously large. So usually I say to row 5 or 6 for quizzes and tests when I give this in things. So any questions? All right, problems are 13, 17. So those are the two where you're just finding the coefficient. Then the actual expansions, let's do 31, 33, 35, no, not 35, 37, and 41. Trying to give you a variety. Some positive, some negative ones. Some raised to an even power, some raised to an odd power. Wait, do you have one raised to an odd power? Yeah, you do. Okay. Anyways. So yeah, quiz on 11.2, 11.3, and 11.4. So that's arithmetic sequences, geometric sequences, and then this binomial theorem stuff on Wednesday. you have a few minutes now, you can work. If you want to do it for homework, you can. You can have a few minutes tomorrow morning when we get to class to finish it up, and then we'll be reviewing a little bit of the different things for the quiz on Wednesday. You could be asked to write out the binomial theorem. That's something that's a possibility on the quiz. I can pretty much guarantee you'll be asked to write a few rows of Pascal's triangle. And then, yeah, we'll talk about the other stuff tomorrow. But from this section, those are two things that I would say make sure you know how to do.